Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC or Diagnostic Trouble Code P0365 relating to the CMP Sensor B circuit, no signal, in Honda Civic models from 2011 to 2015. The CMP or Camshaft Position sensor is vital for engine timing to enable proper ignition and fuel delivery. It provides the engine control module, ECM, with the position of the camshaft, facilitating seamless operation of the engine. When this sensor fails or sends no signal, it can lead to various engine performance issues. In this presentation, we will explore the error descriptions, possible causes, symptoms, and a detailed step-by-step troubleshooting process to effectively diagnose and rectify the issue. This thorough approach will help ensure that the vehicle operates smoothly, minimizing downtime and potentially costly repairs. The CMP Sensor B is integral for determining the camshaft's position, which is crucial for engine timing and performance. It alleviates any confusion regarding the synchronization between the crankshaft and camshaft, permitting the ECM to adjust fuel injection and ignition timing effectively. This sensor resides in close proximity to the camshaft, ensuring accurate and reliable readings. Should it fail or not send a signal, it results in the P0365 DTC being triggered. The ECM, or Engine Control Module, is the primary computer that interprets the sensor's data, thus highlighting the critical nature of this circuit. If there's an interruption or defect in the CMP Sensor B's electrical signal, serious engine performance issues arise, necessitating immediate attention for optimal vehicle operation. Several factors could lead to the triggering of DTC P0365. One potential cause is an open circuit in the wiring associated with the CMP Sensor B. If the wires that connect the sensor to the ECM are damaged or broken, the sensor will be unable to transmit its signals, resulting in no output. Secondly, a faulty CMP Sensor B itself may be the issue. If the sensor is defective, it will not be able to provide accurate position data to the ECM. Finally, the ECM, which is responsible for interpreting and acting on the signals from the CMP, may also malfunction, not recognizing the signals even if they are present. Each of these conditions needs to be thoroughly investigated as they represent significant reasons for the circuit's lack of signal. The symptoms associated with DTC P0365, which indicates a lack of signal from the CMP Sensor B, can significantly affect engine performance. One common issue is engine performance degradation, which may manifest as reduced power, acceleration problems, or stalling. You may also notice that the check engine light is illuminated on the dashboard, alerting the driver to a problem within the engine management system. Additionally, rough idling can occur due to improper fuel and timing adjustments caused by the absence of precise data from the CMP Sensor B. These symptoms advocate for prompt diagnostic procedures to identify and rectify the underlying issues, as they demonstrate a direct impact on the vehicle's drivability and reliability. The first step in diagnosing DTC P0365 involves an initial problem verification. Begin by turning the ignition switch to the on position, which is known as position 2, to power up the vehicle's electronic systems without actually starting the engine. Next, use the HDS or Honda Diagnostic System to clear any existing diagnostic trouble codes stored in the vehicle's computer. This step is crucial because it effectively resets any recorded problems from previous engine cycles. Finally, start the engine to check if DTC P0365 reappears during runtime. If the code is indicated, it confirms that the failure is replicable, warranting further troubleshooting. If not indicated, intermittent failure is suggested, and it's advisable to check for loose connections or poor terminals connecting the CMP Sensor B and ECM. For the second step, your task is to conduct an open wire check of the IGP, ignition power line. Begin by turning the ignition switch to the lock position, which powers down all electronic components for safety. Afterward, disconnect the CMP Sensor B's 3P connector to effectively isolate the sensor from the electrical system. Subsequently, switch the ignition back to on position 2, which activates the electrical system again. Measure the voltage between test points at the connector, specifically from the CMP Sensor B 3P connector number 1, marked yellow with yellow, to body ground. This measurement helps verify if battery voltage is present, confirming the integrity of the IGP wire. If there is battery voltage, it indicates that the wire is functioning properly, allowing you to proceed to the next troubleshooting step. Otherwise, it signals a need for repairs in the IGP wire extending between the CMP Sensor B and the PGM-FI, Program Fuel Injection Main Relay 1. Moving to the third troubleshooting step, the next task is to determine potential failure areas along the TDC line. This involves measuring the voltage at the CMP Sensor B 3P connector, again with the connector disconnected, while ensuring the ignition is in position 2. Focus on test point 1, which is connected to the CMP Sensor B 3P connector number 3 and marked green GRN, and test point 2, which connects to body ground. The goal is to confirm if the voltage reading approaches approximately 5.0 volts, which is indicative of correct voltage levels for sensor operation. Receiving a valid measurement of around 5V implies that the TDC wire is functional, leading you to advance to step 4. However, if the reading is not close to this voltage level, it suggests further investigation is needed into wiring faults, prompting a move to step 5. In the fourth troubleshooting step, you will conduct an open wire check on the LG2 line. Start by measuring the voltage between two specific test points: the CMP Sensor B 3P connector number 1, marked yellow, YEL, and number 2, marked brown, BRN. Ensure the ignition is in the on position 2 and the CMP Sensor B connector remains disconnected. The objective here is to check for the presence of battery voltage, which confirms that the LG2 wire is intact and working properly. If there is battery voltage, this indicates that the wiring is in good condition, allowing you to replace the CMP Sensor B as the next step. If no voltage is detected, it signals an open circuit in the LG2 wire between the CMP Sensor B and the ground G101, needing repair before proceeding further in the troubleshooting process. Step 5 focuses on checking for potential shorted wiring issues in the TDC line. Initiate this step by turning the ignition switch to the lock position to ensure all electronic components are powered down. Afterwards, you need to jump the SCS line using the HDS to prepare for continuity testing. Following this, disconnect the ECM connector C, which consists of 49 pins, to isolate the electronic control module. At this point, check for continuity between the two test points. Firstly, the ECM connector C, where pin number 41, green, connects, and secondly, body ground. If continuity is found, this indicates a short in the TDC wire between the ECM and CMP Sensor B, requiring immediate repair. If there's no continuity detected, the TDC wire is not shorted, allowing you to advance to step 6. The sixth step concentrates on another open wire check along the TDC line. You'll want to ensure that continuity exists between specific test points. Test point 1, the ECM connector C, pin number 41, green, and test point 2, the CMP Sensor B3P connector number 3, green. Maintain the ignition in lock position with both connectors disconnected to ensure accuracy. Discovering continuity at this stage indicates that the TDC wire is functioning correctly. However, if there's no continuity, it suggests an open circuit within the wire that necessitates repair. In addition, as an alternative approach, if the TDC line is intact, consider updating the ECM if it has outdated software, or substitute it with a known good ECM. Proper ECM software updates ensure optimal communication and functionality between the sensor and control unit. Final repair verification is crucial following the troubleshooting procedures. Start by turning the ignition switch to the lock position, allowing you to safely reconnect all previously disconnected connectors, ensuring proper electrical communication throughout the system. After reconnecting, turn the ignition to the on position, second eye, to power on all systems. Use the HDS to reset the ECM, which clears the memory and ensures that all learned values are recalibrated for optimal functionality. The final step entails checking for any pending or confirmed DTCs, ensuring that no lingering codes reappear, particularly DTC P0365. If the code remains indicated, it suggests ongoing issues potentially related to loose connections or a need to substitute the ECM with a known good unit. Conversely, if no codes are present, you can conclude that the troubleshooting and repairs were successful. Implementing preventive maintenance is essential for avoiding future issues related to DTC P0365 and maintaining overall vehicle health. Regular vehicle inspections are crucial, particularly focusing on the CMP sensor connections and wiring integrity. By identifying potential issues early on, repairs can be made before more severe problems evolve. Cleaning connectors, especially those related to the CMP Sensor B and ECM, can mitigate corrosion or dirt buildup that might hinder proper signal transmission. Additionally, keep the vehicle's ECM software updated to the latest version, optimizing communication with sensors. Adopting a proactive maintenance approach will help prolong the lifespan of your vehicle's components and secure reliable operational performance. In summary, understanding the causes and implications of DTC P0365 is critical for maintaining your Honda Civic from 2011 to 2015. The proper function of the CMP Sensor B is vital for engine performance, and recognizing the potential breakdowns can lead to efficient troubleshooting. By diligently following the clearly outlined troubleshooting steps, technicians can identify where faults lie in the wiring or components. Conducting thorough diagnostics ensures accurate repairs are made, safeguarding against future issues. Conclusively, a strong emphasis on preventive maintenance will not only enhance vehicle reliability, but also support long-term operational efficiency. This comprehensive approach to addressing DTC P0365 encapsulates the essence of good automotive service practices. Please like and subscribe to the channel. See you next time.